Hey guys, this is Dr. Callahan with week 3 Friday Algebra 2 semester 2. This is your warm-up, so pause the video and answer the following questions. Okay, so this is week 3 Friday. Let's go ahead and take a look at this. If you already told me what classes you want to go into, I went ahead and already did that. So I either put you into an Algebra 3, Prob and Stats, Trigger Pre-Calc, or there's one more. Did we talk about this, about the class you guys are going to go into? We talked about this, correct? Okay, good. We're intro to pre-calculus. Okay, so if you want to change your mind or you decided to think about it and go, you know what, I thought maybe Prob and Stats is too easy, I want to do something a little bit more difficult, you have until like next week to tell me which one you want, and in which case I'll be more than happy to kind of change that for you guys as well. All right, so then with that said, let's go and take a look today. So we are at the very end of this unit, and when this unit is done, I'm going to have you guys turn this in to me next class on Monday. So you're going to be turning this in, and then I will be giving you guys the brand new packet for the next unit. Okay, so over the weekend, I would suggest the following thing. I would suggest that you watch the video from your QR code, because this one is due on week 4 Monday. And then what I'll do is I will issue you guys a new packet for unit number 4, okay? So over the weekend, my suggestion is make sure you have all guided notes written. So in that case, make sure you watch the YouTube video with the QR code, so that way this is done. If your packet is going to be very empty, that's not good, because what that's telling me is that you didn't do it or you're absent. And if you're absent, that's fine. Things happen. I totally get that. But then it's your responsibility to make sure you watch the QR code and the videos on the QR code, and that you get caught up with it. Okay, but you will have a brand new packet issued to you on Monday. For your Math Excel, keep in mind that your homework is assigned to you every single Monday, and it is due on Sunday by 11 p.m. So every week you will have a homework in addition to a quiz. Although this week I did not assign you guys a quiz, so no quiz for week 3, okay? But you do have the homework on Math Excel. Today is right here, which is on polynomial practice. It is the 21st. And what you're going to need today is the following, and I'm going to change this a little bit. You will need to have highlighters. You need to have worksheet that I'm going to be passing out for you guys. And our objective is specifically going to be looking at even, odd, neither functions of polynomial. So with that said, all right, so let's go ahead and take a look at this then. So first thing I want you guys to do is get to your guided notes, which has number 7 on it. It's like literally the last, I think, 2 examples that's on your packet. And then that is basically it. So let's get to that and go over it. For the student that just walked in and you said you needed all the things, I'm going to go ahead and print this out for you. It's going to come out of the printer right now, my dear. And then that way you have access to it. So over the weekend, I would just suggest you watch the QR code, because all the lessons for this class is on there. And it's just labeled like week 1 Tuesday or week 1 Wednesday. Okay. And you can just follow along with it. And then fill this part out and then turn it into me on Monday. And that's totally fine. So it's printing out right now. All right, so number 7, determine whether this is an even, odd, or neither function. So the way that you do this is you always want to replace the x with a negative x, okay? Always want to replace x with a negative x. And here's the thing. If after I replace x with a negative x, my answer is just the original, it's a positive f of x, then it's an even function. On the other hand, if it's going to be a negative f of x, then it's an odd function. And if it's not even or odd, then your next one that you can write down is it's going to be neither. Okay, so let's test it out. So here I have h, of x. So I'm going to put the negative x in there. And what that means is every time I see there's an x in here, I'm going to replace it with a negative x. Okay. So then remember, I told you guys that if you have a negative number, okay, if it's going to be even on top, like 2, 4, 6, 8, it's going to be a positive, okay? If it's a negative number and you have odd, like 3, 5, 7, etc., then it's going to be a negative. So then looking at this first piece right here, since that is a odd, you know you're going to end up with a negative. Okay, so there's a negative 7x to the 5th. Then if you take a look over here, do you see how 2 is even? So minus, because it's even, it's going to be a positive. It's going to be a positive 2x squared. That negative right here is not from the 2. That negative is from the actual equation, okay? So then from here, negative 7x to the 5th minus 2x squared, you combine the 7 and 2, which is a negative x to the 5th. Oh, I'm sorry, I don't combine. Sorry, that was totally wrong. Negative 7x to the 5th minus 2x squared. Now, when I look at this, is this the original equation? No, it doesn't look like the original equation, because the original equation has a positive 7 and a negative 2, okay? Now, could this be equal to a negative f of x? I'm going to put a question mark right here. Well, if it's a negative f of x, that means I have a negative 7x to the 5th and then a positive 2x squared. So no, it's not equal. So that means it's not even, it's not odd. What is it? It's neither. But that's generally how you test it, okay? And in your packet, that would have been like the last one that you have. And I didn't feel like that was sufficient, so I basically added a little bit more, okay? So now we're going to take a look at the worksheets there. So now let's fill this part out. So this, I think, is the last thing in your packet. Odd function. A polynomial that is odd if it is symmetric about the origin. And you're like, what does that mean? Origin? It means the x and y axis. And you're like, I don't know what that means either. So this is what it means, okay? So if this is my grid, and let's say, for example, I have a little star right here, okay? If I reflect that star across the origin, and this is the origin right here, and I just flip it over here, this is odd. And I know you're thinking like, well, but you also said it was the XY axis. So what does that mean? It's the same thing. Like if I flip this star over the X axis, because do you see how this is the X axis? My star will be right here. But then if I flip it over the Y axis, which is this right here, guess what? My star is at that same location, right? So then this is what it means. If you just flip it over the X, flip it over the Y, it's odd. A polynomial is odd is f of negative x is equal to negative f of x. Like that. On the other hand, a polynomial is even if it is symmetric about the y-axis. And it's just one axis, okay? A polynomial is even if f of negative x equals the original f of x. And so let's draw a diagram to showcase this, okay? So here is my grid. If my star is right here on the left side to begin with, and that star flipped over the y-axis, there's the y-axis, it's flipping over here. If it ends up over there, it is even. So the odd, you just flip it twice. All right, now let's go over here. Take a moment, read the even versus odd on your worksheet. And see if you can fill in any of those blank spaces. So give it a try, you guys. All right, so we can classify the graphs of the functions as either even, odd, or neither. For the left side on the even, a function is an even function if function is an even function if. I'm gonna skip, I don't know what that means. The right side of the equation of an even function does not change if x is replaced by negative x. So what that means, if you replace a negative x, it doesn't change, it equals just f of x, okay? Even functions are symmetric with respect to the y axis. This means we can fold the graph of the axis and it will line up perfectly on both sides. Like if here is my star right there, and I went ahead and folded over the x-axis, my star is still right there. It's just flipped over. Do you guys see that? Okay. On the other hand, if you're looking at odd, every term on the right side of the equation changes signs if x is replaced with a negative x. So if I replace every x with a negative x, then the entire thing becomes negative. So everything becomes negative or opposite signs. Odd functions are symmetric with respect to the origin. Okay, in the origin, this means that we can flip the image upside down and it will appear exactly the same. So then if I have my little star right there, I will have to flip it this way and then flip it this way. So it's right there. And lastly, if you cannot classify a function as even or odd, you call it neither. All right, so let's test your skills on how to identify even, odd, or neither. Okay, so let's take a look at these 6 different pictures. And that's why I had you guys grab highlighters, so that way you can identify the x-axis and the y-axis. So for number 1, is there any way for me to go ahead and fold this picture so it's symmetric? Is it even, odd, or neither? Remember, if it's even, you'll be able to fold it over this way. It's odd if you can fold it over this way and then this way. So number 1, I don't think there's any way for me to fold it and make it look exactly the same. It'll be neither. With number 2, do you see how here I'm highlighting that y-axis? If I were to fold this y-axis and I flip that line over, is it symmetric? Yes, it is. So what does that mean? It means that this one is even. And that's how you generally check. What about number 3? With number 3, if I were to go ahead and draw my y-axis right here, and I just fold it over, does it look like exactly the same? Yep, so this one is also even. If you don't believe me, just imagine like we fold it together. Do you see how this piece will fold into that right side right there? All right, so number 4 is going to be a little bit more challenging. Now, I know that this is my x-axis, and if I ever fold it, they're not the same. Okay, so I know automatically it's not even. But is it odd? And how do I test if it's odd? Let's see. If I flip this piece right here, this is the piece I'm starting off with, okay? If I flip it over this way, do you see how it'll look like this part right there? And then if I flip it one more time over the y-axis, then that piece, guess what? Lines up perfectly with my original image, or that image right there. So this one is odd. And if you're like, but why do I have to start with that piece? Can I start with a different piece? Absolutely. You can start with whatever piece you want, okay? If I decided to start off with this orange piece right here, and then I flipped it over this way, then that orange piece becomes right there. And then I flip this one more time this way, and guess what? It does match that blue piece. So it doesn't matter which way you flip or which way you start off with, but as long as it ends up being the same at the very end, you know it's odd. And then for number 5 and number 6, it's missing. I mean, like there's number 5 looks just like number 1, so it's a neither. And number 6, it's like missing the other half. Now, if number 6, I had another piece right here, then it will be symmetric, but it's not even or odd. So this is also neither. Okay. All right. To verify algebraically if a function is even or odd, or neither, we must prove one of the following. For even, you prove that f of x has no sign change. For odd, remember it has the negative f of x. That means all signs change. So I have a little chart of what to do to break it down for you guys a little bit easier to understand and comprehend, okay? So here you have function notation, f of x, repeat the original function. Well, what does f of x equal? Just x squared plus 3x plus 5. So nothing changed. That's the original function. If you plug in a negative in here, so you plug in a negative x for every x and simplify. So let's do that. So f of negative x is equal to negative x squared plus 3 times negative x plus 5. And remember, since this is even, you have a positive x squared at the end. 3 times negative x is a negative 3x plus 5. When I go ahead and take a look what I have here, and I go ahead and compare this to this, is that the original? Nope, the signs did not change. So I know it's not the original. So guess what? It's not even. Is this going to be opposite signs? Well, opposite sign will mean it's a negative x squared, negative 3x, negative 5. Nope, it's not odd. So what is this one? It's neither. And that's generally how you check. Now over here, f of negative f of x, change every sign you see in the f of x. If something starts positive, it changes to negative. And if it starts negative, it changes to a positive. So for here, negative f of x will mean positive x squared is a negative x squared. Positive 3x is a negative 3x. Positive 5 is a negative 5. And again, if you take the middle one and then compare it to the bottom, does it look like that? Nope. it doesn't. The signs are different, so it's definitely not odd. So now that we have those three conditions, let's try and practice and see if it's even, odd, or neither. I'm going to give you guys a function. You're going to plug in the numbers and see if it is. I'm going to skip number 1. We're just going to jump over to number 2. Okay, so we're going to go on to the second page. I know you're like, why are we skipping example 1? Because example 1 is neither, and I feel like we've done a lot that was neither. So I'm like, meh, let's just skip it. So give it a try. For number 2, plug in g of negative x and ask yourself, does it give me a f of x or a negative f of x? So give it a try. Okay, so looking at number 2 right here, we're going to do g of negative x. So every time you see an x, we're going to replace it with a negative x, the 4th, minus 2 negative x squared. Okay. Now remember, this is an even, so that means I'm going to end up with a positive x to the 4th. This is an even, so I'm going to end up with a positive 2x squared. I want to go ahead and simplify that a little bit more, so then I'm going to end up with x to the 4th minus 2x squared. So this is my final answer, okay? So then what I'm going to do is I'm going to compare my final answer and ask myself, is my final answer going to give me the original f of x, or is it going to be a negative f of x? And I put a question mark there because I really don't know. So then I look at the original equation. The original equation is x to the 4th minus 2x squared. This is my final answer. Does it match to the original g of x? It looks like it does because you have a positive and then a negative. Yes, it does. Since this is equal to f of x, or I shouldn't say f of x, g of x. Sorry, my letters are different. G of x. Then I know that f of negative x equals, or sorry, not f, g of negative x equals the original g of x. So what is your determination? This is indeed even. And don't worry, we're going to practice one that has an odd one as well, so you can tell. Now I'm going to have you guys skip down to number 5. So take a look at number 5. If you have your cell phone out, you guys, please put your cell phone down so you're paying attention to this. This is important. It's our last section, I promise. So I'm going to put in a negative x. So 7 times negative x, the 3rd minus negative x. And again, you're going to look at this piece right here. Notice that this piece, this is an odd, which means it's going to be a negative. So your answer here is negative 7x to the 3rd. Negative and a negative makes it a positive x. So this right here is your final answer. And you're going to ask yourself, is this equal to f of x, or is this a negative f of x? Well, f of x just means that it's the original. And I can tell like the signs are not matching up. So does that mean it's equal to a negative f of x? A negative f of x means all the signs here have to be opposite. So that has to be a negative 7x cubed plus x. Does this match that? Yes, it does. So then you could say that my g of negative x is equal to a negative g of x. So yes. So what does that mean? That means it's going to be odd. It's just kind of like trial and error. And I know you're like, oh, why is this important? When you guys get out of this class next year, whether, I mean, most of you guys I think are juniors, so I don't think anybody here is a senior, but even if you are a senior, when you go into Algebra 3, you probably won't be doing much of this. But if you're going to Prop and Stats, it's like another higher level than Algebra 3. And then if you go to Introduction to Pre-Calculus, that one you'll do this a lot. And then you go to the highest level of class, which is Trig and Pre-Calculus, this is a lot of it as well. So just think about like, you know, where you're going. And I want to make sure I go over everything with you guys so that you're adequately prepared for next year. All right, let's go ahead and jump back over to number 3. So for number 3, is it even, odd, or neither? Let's check. So I'm going to do h of negative x is equal to negative x squared plus 2 times negative x plus 1. That 2 is even. So if it's even, remember it's positive. So it's a positive x squared. 2 times negative x is a negative 2x plus 1. This is my final answer. And when I ask myself, is this going to be original f of x, which is even? Is going to be a negative f of x, which is odd? Or it could really be neither. I mean, if it's not even or odd. Well, let's check. Original f of x is x squared plus 2x plus 1. That doesn't match. The signs are not there. So then what about negative f of x? Negative f of x means it's going to be a negative x squared minus 2x minus 1. Does that match that? Nope, it doesn't match. So if it's not even, it's not odd, what's left? Neither. And that's how you make that determination. So I know you're like, this is a lot of work, and I totally get it, but just keep in mind that if you chose to go into, you know, some of the higher level classes next year, you'll definitely go over this. And I know that because I teach as AP Calculus, which is the highest level math that you can take in high school. And we'd use this like at the very beginning of my class. So I definitely know for a fact, if you're going to pre-calculus or introduction to pre-calculus, you definitely use this. All right, so then for the rest of the time, I want you guys to just kind of practice with this. Now, we have gone over number 2, we did number 3 and number 5. And so I would like you guys to focus on number 4, 6, 7, 8, and 9, and 10, okay? But before I do that, I'm gonna have you guys go right down over here to this little box. And I'm gonna show you guys a video. So if you are like, I'm still a little bit confused by this, maybe I didn't do a very good job explaining it to you, and that happens, you know, sometimes like, you know, what I say might make sense to certain people, but it might not make sense to other people. And so I want to share this little video with you guys. So let me, oh, whoops. Okay, you guys, so I'm gonna have you guys just kind of practice with this. So go back to this last page that we were just on, and then you guys can pick any other questions that we have already gone over and just practice with it for the last few minutes of class, okay? All right, you guys, so your exit ticket is gonna be right here. So grab your cell phone or your iPad, just go onto the QR code, type in your first and last name so that way I know you have it. And just remember, like, you don't have to be good at math to pass this class, but you do have to put in the effort to at least get a D. So as long as I get your name and you answer the questions, and it's not really math related, as long as you do the reflection on it, you will get the points for that. You guys have time in class, so you have about 8 minutes